let us look at the conjugate points on a sphere. We have already touched on this subject in a previous video, but now let's go through it in a bit more detail. We have the sphere here, and we have the great arc that travels around the sphere. We have a point A on the great arc, and when we go to the point diametrically opposite, this will be A dash, and this will be the conjugate of A. Now let's say, for example, we were travelling around a point on the surface of the sphere. So you can see here we've got our X, Y and our Z axes. Now we could travel around in the XY plane, so that's in this plane here. So we could travel round an angle of phi. Now that phi would be the longitude. Now let's say, for example, we then moved up the sphere at this angle here. Then the angle of theta, which is actually the 90 degrees minus this angle, we could call this the colatitude. Now we've seen in the previous course, whenever we looked at the sphere, that we can derive the great arc on a sphere if we think about having a plane which runs through the centre of the sphere. So if you've got any plane has a point which is the centre of the sphere, the intersection between that plane and the outer edge of the sphere will provide us with the great arc. Now we've gone through that derivation in the previous course, so you can also always have a recap and have a look back and see that derivation. So we derived the equation of the great arc in that manner, and it's given by this equation here, or cos phi plus beta equals tan alpha upon tan theta. Now we're not going to go over that equation again, so have a look back in the previous course and you'll see where that came from. Now what we want to be able to show is that if we have a point A, which is given by the angle theta naught, comma phi naught, okay, so there's our theta naught and our phi naught, gives us a point on this surface. Then we're going to look at the point which is diametrically opposite, and the diametrically opposite point is going to be given by the point A dash, which is going to be the angle phi naught. So we still come round the phi naught, but instead of going up the angle theta naught, so instead of going up here, we're going to go up theta naught, and we're going to add pi onto it. So the pi is going to be 180 degrees. So instead of at this point here, it's going to be diametrically opposite. It's going to be 180 degrees the other direction. So we're going to get the point which is A dash, which is diametrically opposite the point A. Now we have to prove that this is the case. So let's go ahead and we'll do that on the next page. So we're going to start off by making the angle theta the independent variable, and we'll make phi the dependent variable. So what we'll do is we'll rewrite our equation in this format here. So we'll write it in terms of phi in terms of the angle theta. So if we just go back to the previous slide here, you'll see that we've just rewritten this here in terms of the phi being the independent variable. So we take the inverse of this and the inverse of this, and then we shuffle the beta across to the other side. So we're just going to be left with this function here. So now what we have to do is we have to apply our calculus of variations, where we learned how to find the conjugate points analytically. So this is the equation for finding the conjugate points analytically, and if you note here, I should have this here as well. That should be up here. So we've seen this equation in the previous video when we used it, and we've derived it a couple of videos ago. Now we want to do these differentiations here, so we want to do our partial phi by partial alpha, partial phi by partial beta, and we're going to make that equal to partial phi by alpha, partial phi by beta, and we'll say that theta is equal to theta naught. So we're going to use these two identities here. So if I find the differentiate the inverse cos, it's going to give us this 1 upon 1 minus x squared to the power of a half. So that's a standard differentiation. So, and also the tan x here, when I differentiate tan x, it's going to give us the sec squared x. So let's go ahead and we'll differentiate this. So if we were to differentiate this thing here, let's say partial phi by partial alpha. So we're differentiating this here with respect to alpha. Now you can see that in that case here, our tan theta would just act like a constant because we're differentiating it with respect to the value of alpha. And we're going to have a function of a function. So we're differentiating, it's going to be inverse cos of this value here, which we could just say call x. But x again is going to be tan alpha upon tan theta. So we've got the chain rule for differentiation. So we know that inverse cos of some value x is going to be given by 1 upon 1 minus x squared to the power of a half. And we know the value of x is going to be our tan alpha upon this tan theta, where tan theta is a constant. So we're going to have to differentiate what's inside the bracket. So when we differentiate this, well, the tan theta is a constant, so it just comes out as a constant. You've got that coming out here as a constant. And when we differentiate the tan alpha, we can see here that we differentiate tan of this value, it becomes sec squared. So we're just going to have the sec squared alpha upon tan theta. So that's going to the two that are going to come out. And the f derived of x for this inverse cos is going to be 1 upon 1 minus x squared to the power of a half. So it's going to be 1 upon 1 minus, now x in this case is our tan alpha upon tan theta. So it's going to be our tan squared alpha upon tan squared theta. And I've noticed there that I've missed out to the power of a half. So that's all of this, 1 minus x squared to the power of a half. So it should be a bracket around that, a bracket around that, and that's all to the power of a half. And it's same whenever we go to the other side, but the only difference now is we're going to be replacing the value of theta with the value of theta naught. So let's just, so this is exactly the same as this, but theta is replaced with theta naught. And again, we're going to have to power of a half around this. So if you get stuck with the differentiations, you can always just give me a shout and I can talk you over if you're unsure. Now from this line to this line, what we'll do is we'll take the reciprocal of each of these and then we'll square them. So if I take the reciprocal of this section here, it'll be our tan theta upon sec squared alpha. And again, we'll have our tan theta naught will be in the top and sec squared alpha will be in the bottom. So it means that we can just cancel out the sec squared alphas from each side. So we would be left then just with the tan theta here and the tan theta naught. And as I said, we're going to square them as well. So we'll get our tan squared theta and tan squared theta naught. And again, when we take the reciprocal of what's inside the brackets, we're going to be left with our 1 minus our tan squared alpha upon tan squared theta, and the power of a half just disappears because we've squared it, and the same on this side as well. So we're going to be left with this equation here. Now when we multiply out the brackets here, we'll have our tan squared theta, that's that one there. This will cancel with that and I'll be left with our minus tan squared alpha. And on this side here, we're going to have tan squared theta naught. So that's a tan squared theta naught. This will cancel with that and we'll be left with our minus tan squared alpha. Now the minus tan squared alpha here will cancel with the minus tan squared alpha and we'll be simply left with tan theta equals tan theta naught. So now we know that the tangent function is going to repeat every pi radians. So it means that the solution to this here is going to be theta is equal to theta naught plus m pi, where m is some integer. So we've shown here then that if we have a point A, theta naught, phi naught. Then the conjugate point is going to be a dash, which will be theta naught plus pi. So in this case here, we can take m multiples of pi, as many as we would like. We'll still end up come back to the same point, comma phi naught. So we've shown then that using the analytic method that the conjugate points on a sphere are diametrically opposite. That's all for this video. Thank you for watching. I'll get you on the next video. Goodbye.